All right, you guys got these 5 right here? Yeah, let's do number 3 right up and count. So this is 5 divided by 11 actually, which would read as 5 divided by 11, like this. Now, of course, 0 doesn't go into 5, so we'll move the decimal up and make this 50. Well, 11 will go into 50 4 times. And yeah, just throw it away. 4 times 11 is 44. So when I subtract that, I get 6 remaining. Now 6 is too small for 11 to go into, so I'll drop the next 0 and make this 60. And 11 will go into 60 5 times. 5 times 11 is 55. Now at this point, when I subtract, I get 5, right? And I could say, you know what, I'm going to drop another 0 right here. Well, we've seen 50 before up here with, well, this up 50 right there. Okay, which means that these two are going to repeat. There we go. There's a little typo on number 2, but we got it. Now, this is this is crucial for you guys to understand. Look, if you guys can just understand, please, that math really is just, I mean, there's theoretical math and stuff, but right now the math that we're learning is more based on you being able to manipulate and force the numbers to do what you want them to do, right? Because in the past, the numbers have taken advantage of people's, which is unfortunate because numbers don't have feelings, they don't have emotions, they just exist, all right? In fact, man created the numbers, and now they take advantage of people, and sometimes, you know, it destroys lives, okay? So what we need you guys to do in this class is learn to take control of the numbers so that they won't take control of you, okay? And bend the numbers, the math, to your will. Because once you do that, there's nothing you can't do in terms of math goes, okay? You can go all the way up into math theory, and it's like, dude, I'm still forcing things to do what I want it to do. It's pretty good. It will empower you for the rest of your life. Well, there's our objective. I can use rates and unit rates in solve proportions. Oh, it's pretty good. You guys take a minute to copy that down. All right, ratios is fractions and lowest terms. The ratio is just a comparison between two numbers, you guys. So if you're looking at strictly numbers, I mean, you can label the numbers, and that's fine. But once you label it, it really becomes a rate at that point. Because rates are a comparison between two quantities. Again, that just means that the numbers then are labeled. They could be labeled in inches or feet, like measurement, or they could be labeled in other types of units, like peoples or dollars or hours or something like that, okay? But yeah, once you slap labels on those numbers, bam, you've made a rate. Otherwise, it's ratio. Well, what does that mean the difference is? Mathematically, none, okay? Other than one still has labels and one doesn't, okay? Now, ratios in the past, you guys have seen these written differently, right? Like if we compare two values, let's just look at 1 and 2. It's pretty good. Now, in the past, it'd say you're going to compare 1 and 2 as a ratio, so they'd put this, I think it's called a colon. Now, do I care if it's called a colon? I don't. Because it could be called a semicolon, and I just don't know, okay? However, there's other ways to write a ratio of 1 to 2, and this reads 1 to 2. You could actually write the word 2 between it. 1 to 2. 1, 2, 2. Yeah, I don't... Sorry, that maybe I shouldn't have used 2. But in any case, some people don't understand that there is kind of an operation between there, all right? Like if you looked at this ratio with the colon thing, or whatever the crap it is, it's like, well, that's really just part of the operation division right there. It's 1 to 2. So you could read that as 1 divided by 2, but if you wanted to, for some reason, like, you know, just talking to people, suddenly change that to 1, 2, 2, then they'd be like, oh, that was weird. Okay? But there's other ways to write it, such as 1 to 2. Or you could write it as 1 to 2. Or you could write it as 1 to 2. See what I'm saying? So many different ways to write ratios. Now, the point that I'm getting at with the whole division part of that and the fraction and all that business is that it's really 1 divided by 2 is what it comes out to, right? Now, we don't really need to change those numbers or do the division but eventually we might. And that's why it's talking about fractions in lowest terms, because a ratio is a fraction. And if you can simplify the fraction, that'd be good. Okay? Now a rate, well, how do we change these into rates? You just give them labels, like this one, right? If I said, let's look at this fraction. We deal with a lot with fractions like this. And it's like, right now it's a ratio, but we want to change it into a rate. All right, well, we'll make this one leprechaun. And no, I don't know how to spell leprechaun, okay? Now I understand. I spelt that horribly wrong. But I have a feeling you don't actually know how to spell it either. I just have a feeling that you don't, that's all. That's all I'm saying. In any case, leprechaun. And then we could compare leprechauns to whatever you want, like, I don't know, unicorns. Now, I know I hurt people's feelings on that. And again, the truth is I don't know how to spell, but they don't exist either way. Sorry to burst your bubble on that one, too. So now this is a rate instead of a ratio. That's it. All right, so rates. So rates, whenever a ratio compares two quantities that have different units, then the ratio is called a rate, just like we saw. And we see one at the bottom there. For example, if we were to travel 120 miles in 3 hours, then we'd be going extraordinarily slow, which may be the purpose. I mean, if you're in a car anyways. If you're running, that's really fast. Then our average rate of speed expressed as the ratio of miles to hours, right? And just so we understand, this given as a ratio, just without the numbers, again, I'm going to write it as a fraction, miles to hours, right? So miles is in the numerator, and hours is in the denominator, which is why we see it over here that way. Now notice they don't say you got a miles to hours ratio of 120 to 3 miles to 3 hours. And then suddenly it changed from hours to miles. So wherever you put the labels, miles in the numerator and hours in the denominator in this case, keep them there. Now does that mean you could have written it as an hours to miles ratio? You could have. But they said it's a miles to hours ratio, so that's the way we wrote it. Okay? So that's another thing about rates, is that where you put the labels is not as important, right now anyways, as just making sure it's consistent throughout. Okay, so make sure that wherever you put the labels, just keep them there. Okay. Now this one shows us just a regular old-fashioned ratio. It looks very pretty. But we need to write this in lowest terms. The answer should not contain decimals. In fact, I'm going to write this answer as a fraction. These fractions are so pretty. So like this one, as a fraction, this would be written as 22 to, that's the fraction bar right there, 16. Well, if you're looking to reduce this, there's a couple ways to do it. All right, the first way that I'm going to show on this one anyways is just to use scale factors. I'm going to scale this thing down because I see they're both divisible by 2, right? So I say 22 divided by 2 is 11, and 16 divided by 2 is 8. Now, going back to what we talked about at the beginning of this lesson, is taking control of the math, right? The numbers. So I didn't want to see 22 over 16. I wanted to see something smaller, like 11 over 8. Now you could take even further control and say, you know what, I want a different denominator but equivalent fraction, right? I didn't change the value of the fraction in red from black to red there. All I did is change the way it looked. Now in this class we're going to say that that's as simplified as we can go because I don't have any common factors between 11 and 8 to simplify this from, okay? So that's it. Now again, talking about fractions, which I think we've talked about before, but I want to re-emphasize this. Some of you guys are like, dude, I got to change this into a mixed number because some elementary teacher a long time ago, while giving you a hug, told you to change this to a mixed number. Don't do it. Well, you can. Just be careful, okay? In fact, that brings us to the second method, which let me see if the next one's good. So the second method on this one, I'm going to show both methods on this one, okay? Now again, this shows a ratio of 6/7 to 1/7, like this. And by the way, this is just fraction division right here. So 6/7 divided by 1/7. And it's true that we do not divide fractions, we only multiply them as long as we reciprocate the second fraction, right? So that becomes 7 over 1. So now we've got 6/7 times 7/1. And sure enough, the 7s are both divisible by 7. 7 divided by 7 is 1, and 7 divided by 7 is 1. And fraction multiplication, which shows 6 times the 1 right there is 6. And 1 times the 1 in the denominator is 1. But I'm just going to make this a phantom 1 right there. Okay. So the final answer to this was 6. Well, I'm going to show you a different way, and you can decide if this other way is easier for you. Maybe you'll hate it. But it's not required that you use any specific method on this stuff. Okay. Actually, maybe I'll show you a third method, because this some students like to show like the fraction, compound fraction rainbows like this. You got the 6 times 7 on the outsides and the 7 times 1 on the insides. I don't know. Some people like that. But this is the other way. This is my favorite way, actually. So here's what you got, right? We got 6/7, 2, which is really division, 1/7. So what I do when I solve this is I grab my calculator and I type in 6, and then there's this N over D button. It's 3 buttons above 7. I push that button. And the fraction says, oh, you wanted a fraction? I'm sorry, the calculator says, you wanted a fraction? And yeah, that's why I pushed the button. Jeez. So after I push that, then I push 7, which is in the denominator, and then I push the over button, so that I'm out of the fraction. Then I push the divide button. Then I push the fraction button again. I push a 1 in the numerator, a 7 in the denominator. I push equals, and bam, the calculator spits out the answer that we saw right there in red as 6. Now, you get to decide, was that more work? Maybe. It was a lot more talking, but was it more work? I don't know. You have to decide. But I really like this method because the calculator did all the work. All right, here's one. Now before, like in the last unit, because we couldn't use calculators, would say, oh, we got to change these into improper fractions and then use the division. And that would require changing the operation of multiplication and reciprocating the second fraction there, right? But not today, because we're using calculator. All right? Yeah, no, for reals, man. So I'll even show the button progression on this one, okay? All right, let's see what buttons we got to push, okay? Now, these are mixed numbers, and as it turns out, you can't type mixed numbers into these calculators. So at the top left, you're going to see in these yellow calculators we got in class, the second button. Very top left, it looks just like this. It's even green. You're going to push that button, and then if you go 2 buttons down and 1 to the right, you're going to see this N over D button. That's the fraction button. Okay, now if you look right above that in writing, it shows U and D. That means you're telling the calculator, hey, I want a mixed number. And then it'll say, oh, you want a mixed number? Okay, you got one. And now I type the number 14. That would be 2 buttons, by the way. But I don't have the space to put it in there. And then that would put 14 in as the whole value in there. But then I push this, the cursor button. It's on the oval. I'm just going to push to the right, and that's going to put me into the numerator of the fraction. Well, I want 1. Now I'm going to go push the down arrow on that same oval. And that's going to put me in the denominator, and I want a 2 as my denominator, okay? Now, I need to get out of the fraction, so I'm going to push over on the cursor, which takes me out. And I got 1 over 2 now. So you can see the actual mixed number, 14 and 1/2. And the calculator knows, again, you want a mixed number. Well, this is a ratio, so I'm going to put division, right? So I'm going to push divide. And then I got to type in this next one. So I got to push the second button, and then the N over D button, and the second N over D. And this whole value is 5. And again, I got to get into the numerator right there, so I got to push over, then 1, and then down, and then 2. Yeah, 1 over 2. And then the final button we're going to push, I don't have the space to push enter, but I'm going to put equals. So I'm going to push enter, and final 2, enter, and it gives me this fraction, 29 over 11, and I am done. Alright, now this one has a decimal on this one. Now see if you can write this one in as a fraction in lowest terms, okay? 1 minute, go. For this one, I'm still going to use the N over D button, you guys. In fact, that's the first one I would probably push on this one. Then after that, I'll type in 0.5. And again, that's 3 buttons right there for me. Then you're going to push the down arrow to get to the denominator. And then you'll type in 15. And then the enter button. And I'm just going to push equals. Now the problem with this, when I put this in the calculator, it gives me 0.03 repeating, right? Well, I didn't want the decimal. That's what it said above. It wants the fraction. Well, if you look at the enter button, just right above it, there's this button right here. If you push it, just push it, then it will give you the fraction, 1 over 30. I know. I'm not a magician, by the way. It's all built in the calculator. All right, guys, try this one. 30 seconds, go! I like this one. I like this one a lot, actually, and here's why: is because this is a rate. It should say rate, not ratio. 370 milligrams to 50 milliliters. Okay. Now these are very different types of units. One is weight, and one is a capacity, like volume kind of thing. So we're not actually looking to change the labels on this one. We got milligrams to milliliters. That's the same ratio we want. It just needs to be simplified. And I would have noticed that the zeros could have been canceled out right there to make this 37 milligrams to 5 milliliters. And I'm done. So this brings us to unit rates. A unit rate is a rate. Now remember, a rate is where we're comparing two different quantities like we just barely did with milligrams and milliliters. But one of the quantities has to be 1. So in that last example, if you wanted to reduce it, and you could have decimals in this case, okay? But one of the quantities has to be 1. So like on that last example, maybe milliliters is 1. Like you want to know how many milligrams to 1 milliliter. Or maybe you wanted 1 milligram, so you'd figure out how many milliliters for 1 milligram, okay? Now you could write these as fractional, kind of like compound fractional rates, which is okay as well, depending on what it may be asking for. So let's look at this one, and we'll see if we can reduce this into a rate. Now it says kilometers per hour. Now there's a phantom 1 right there. It's a phantom, per 1 hour is really what it's asking for. So if we were to look at this, it's kilometers per hour. That's the rate, the ratio, if you will, kilometers to hours. So I'm going to keep my fraction with kilometers in the numerator and hours in the denominator. Well, what was the immediate relationship that it gave us? It was 492 kilometers or kilometers to 6 hours like this. But it says it wants to know how many kilometers for 1 hour, like this. Now again, notice the units stayed where they were. Kilometers in the numerator, hours in the denominator. We didn't suddenly switch them for some freaky reason, okay? Well, how do we figure this out? Here's what I'm going to do. Is I'm going to type 492 divided by 6 in my calculator and then see what it gives me. Now, this one told me it was 82. So, that is all. 82 kilometers per hour. Now, how can we know this? Well, if you did 82 plus 82 plus 82, that'd be 3 hours, plus another 82 is 4 hours, another 82 is 5 hours, another 82 is 6 hours, 492 kilometers, and that is all. Now, here's the thing, though, is if you analyze this and you did 492 divided by 6, but you got a decimal, again, that's okay in a unit rate like this, okay? Because sometimes we do need to, maybe we'll have to round these, okay? So just be aware that that may happen from time to time. All right, a car pulling a trailer can travel 144 miles on 90 liters of gas. What is the gas mileage in miles per liter? All right, well, you guys take 30 seconds and see if you can figure this one out. 30 seconds, go! So yeah, we bring up this other question, right? Well, we know it's a fraction, as the rate is a fraction. The ratio is a fraction as well. But, well, how do we know which one goes first? Remember, it's always something to something. It's just, now it's saying something per something. So if you wanted to, you could really just look at this as miles to I guess liters in this case. Yeah, liters. Well, that means that the first one always goes in the numerator, and the second one is always your denominator label, okay? And this is miles per liter, and again, the relationship that they gave us was 144 miles for 90 liters. It's not very good. But what we want to know, and again, it's got to be equivalent to this, okay? This is going to figure out miles to liters ratio still, or rate. It's just now we want to know how many miles for 1 liter. Now, it only said per liter, but again, you could put a 1 right there if you needed to, okay? Well, here's what's really happening, you guys, is we're scaling this down, specifically the 90 liters into 1 liter. Okay, so really what we're doing is dividing this by 90 to get this 1 over here. So we'll do the same thing to 144, divide that by 90 to get its new mileage. So I type this into the calculator, 144 divided by 90. Oh, that's a pretty nice decimal actually, 1.6. Now, again, on most standards, I mean, if this was like one of those old Sherman tanks, maybe that's pretty good, but it still seems pretty crappy gas mileage. So 1.6 miles per 1 liter. That would be our final rate, specifically unit rate, again, because it's showing 1 liter. And once one of the values is 1, then it is a unit rate. It's very different together. At the beginning of a trip, the odometer on a car read 32,825 miles. At the end of the trip, it read 33,014.8 miles. If the trip took 3 3/4 hours, that's a mixed number there, what was the rate of the car in miles per 1 hour to the nearest tenth? Oh, very good. Well, here's what we want. We want number of miles per hour, right? It says the rate of the car. So now you could do, well, no, it did say, I'm sorry, it says miles per hour right there. Miles per hour. So miles in the numerator, hours in the denominator. Well, the question is, how many miles did they travel? And right here we see that at the beginning of the trip, the odometer read this 32,825 miles, right? And then at the end of the trip, it said it was 33,014.8 miles. Well, to figure out how far they drove, we're going to subtract these two. And while some of you guys could do that pretty quick in your head, I'm just going to do it in the calculator because I love it so much. So, oh, I pushed the wrong button up and down. Get rid of that decimal. Ooh. That's not what I wanted. Delete. There we go. Oh, I got 100. Oh, that's not very many miles. 189.8 miles. That's an M. So they went 189.8 miles, and they said the trip took 3 3/4 hours. Okay, so again, this is 3 3/4 right here. Now, why am I writing this as mixed numbers? Because in my calculator, I can enter it as a mixed number. So I got 189.8. Then I push my fraction button. Then I do second N over D. And I can put this in there directly, 3 3/4. Bam, and get 50. This is showing 50 point. It says to round to the nearest tenth, I guess. I got 6-1, so I'm just going to make it 6 right there. Well, what's the label on this one? Now, we've been showing it as a fraction like this. 50.6 miles for 1 hour. That's not actually that bad. But if you wanted to, some students are like, I can just write 50.6, because this is a very common acronym, doesn't seem like the right word, but MPH, miles per hour, on that would work. Either one of those would work. Now, I prefer the fraction because it specifies the miles to hours, and in fact, it even shows the 1 hour right there. Plus, it keeps it organized with the fractions we were working with before. Proportions. A proportion is when two fractions or rates are equal. In fact, we've been dealing with that in the last several problems, especially with unit rates. Okay, so you're going to take those and you're going to simplify them. Yep. Now, there's several different ways to solve proportions. Let's see if we can figure them out. Okay. So when we talk about proportions, it's kind of like, I don't know, I guess we can use a, you guys want me to use a pizza, brownies, or a sandwich?
Sandwich.
Brownies, alright, the brownies went out. Oh yeah, too late, man, too late. Well, it's like a pan of brownies like this, and I don't like models, but I like this one because I'm talking about brownies, and I love brownies.
Really?
Now, in some families, they have what they call, I guess, leftovers of brownies.
Wait, what?
So, yeah, no, I'm serious. Like, some people have been like, there's leftovers. It's like, what the crap is that garbage? All right, well, in some families, they got these leftover things, and they're like, you know, our family, we only ate half of the pan of brownies, so you got all these brownies on this side. Well, you know what, I'll say this was all eaten. This was eaten right here, okay? So they ate all these brownies, but then they got quote-unquote leftovers. And then it's like, well, what are we going to do with these leftovers? Well, in fact, in relationship to this lesson, it's like, well, how much leftovers do we got? Well, this would be one out of two pieces, right? But the truth is, if I said, you know what, let's cut that in half, would you rather have one out of two pieces of brownies or two out of four?
Two out of four.
Well, as it turns out, they are the same. It's just one's cut into smaller pieces, which actually could be a little aggravating. It's like, I want to see the giant piece, right? Well, you could continue to cut this like this, and now you could have these four pieces right here. 4 pieces out of 8, what would have been 8 pieces. Now again, are you getting any more or less brownies? No. They're all the same, and this is where proportions come from. Brownies. This first way that I'm going to do this one, and we're going to solve for x on this one, right? This first method is called scale factors. So I literally am just scaling the numbers. And this is the nice thing about proportions, is that there's a relationship up and down between the 3 and 7 and 6 and x. But I don't really see a direct relationship between 3 and 7. Now when I say relationship, I'm looking for multiples or factors of one or the other. But there's also a relationship left and right between these. And with 3 and 6, I see the relationship. For 3 to 6, I would multiply the 3 by 2 to get 6. So to scale this up properly, I'd have to multiply the denominator by the same thing. And 7 times 2 means that x being 14 would be the solution on this one. So in other words, 3/7 as a fraction is exactly the same as 6/14. All right, 10 seconds, solve this one. On this one, again, scale factors I see is a very easy one to use because in order to make a 6 a 3, I would just simply divide it by 2. Right, so I could take the 7 and divide it by 2 to get the x over here. And 7 divided by 2 is 3.5. Now this one wants the fraction, right? So if I put 3.5 in the calculator, let's see, 3.5. If I push that double arrow button right above the equal sign, it gives me even further 7 over 2. Which some of you guys may have known already. No mixed numbers on that. We want the improper fraction. Yeah, let's address that. So this would have been 7 over 2 all over 3, like this. Its equivalent fraction in sixths would have been 7 of these sixths. Now this one has some fractions in it. Let's try this one a little different, and then you guys can decide which way you like the best. By the way, the scale factors will work on this one. I know 7/11 is the same as 7 times 1/11. So I could just take the 8 times 7 and get 56 pretty quick. However, most people wouldn't notice that, so I'm not going to do it that way. I'm going to use the second method for solving proportions, which is cross multiplication. And you guys probably heard this before, because some of you guys have gotten cross simplification up. You mixed it with cross multiplication. As it turns out, the cross multiplying, so that would be like 7/11. It is being multiplied by the 8 with its cross, equals the other one being crossed, which is y times 1/11, like this. Now this kind of goes into the next section, which we'll delve more into. But for now, you could do, you know what? It'd be 7/11 times 8 once. You can just put it in the calculator as well. It's 56/11 equals, I'm going to change this up to look a little bit more pretty, 1 over 11. So you guys see the 11 thing right there. once you get denominators like that the same, you can just start to erase it. And but I'm not going to. I'm going to divide both sides by 1 over 11. There's a purpose for that, although right now we're just worried about the algorithm. So we'll talk about the y's later. And so I type 56 over 11 as a fraction, all over 1 over 11 as a fraction, and it gives me 56. So this means if you replace the y there with 56, these two fractions are actually equivalent in value. You wouldn't have any more pizza or brownies or sandwich or whatever the crap you're talking about. Now, a lot of students look at this one like, hey, that's not a proportion right there. Oh, it is. Well, how is it a fraction? Remember, we can write 6 as 6 over 1. It's a phantom divide by 1 right there. So on this one, scale factors is nice because I see 1 times 19 is, 19. So I can just multiply the 6 by 19 and get my y value. And 6 times 19, that's a 60 and 110, 114. Y is 114. You can put in the calculator 6 times 19. Should give you the same answer. Oh, what about decimals? Let's use the third method that we teach for solving these. Now, if you hate any of these methods, well, actually, most students hate all of them.
Yeah.
But you got to choose one that you like the most so that hopefully you can use it more often than, I guess, not. This is called fish method. I like fish method, actually. So we see that there's 4 values in this. 1, 2, 3, 4. And this is almost purely algorithmic, right? Like, hey, this is the process you do, and if you do it every time, it works. It's always multiply, then divide, and then it's equals. Well, we want to know what the n equals, so that's always the n right there. Okay, so you can always fill that in with whatever letter it's using. And now we apply fish method. Well, for fish method, you always start with the letter. And yeah, we're going to draw a fish. Now, this fish is going to be extremely artistic for a math class. And we always start by drawing the tail. Now, the tail for math art class now is always an up and down line. So I can see from the end I'd have to go down, and that'd be 0.6. That's the first number I encounter, so it's the first value I plug in to this formula, I guess. And then the thing is, if I cross it up here, then the next number I encounter is 0.25. Now, some of you guys see how the fish is forming right there, right? Then I curve it back around, and that creates the head of the fish. And then I got the next number, 0.15. And you always end at the letter the same place you started, which in this case is N. Now, we like these fishes. A lot of the times they're happy, like this. Sometimes they're kind of like an angry happy, you know what I'm saying? I wouldn't want to encounter this guy, but in any case, seems like he's missing some fins, but it's math art class, okay? Well, how do you solve this? Just type it in, 0.6, you gotta type this in, 0.6 times 0.25 divided by 0.15, bam, 1. Oh, it's 1. N is 1. This value right here is 1. 1! Now, I like fish method. I'm very partial to it because I like drawing fish. Math fish, you know what I'm saying? Alright, I'm going to do a fish method on this one too. And so again, we got 4 values. 4 values, very nice. It's always multiply, divide, then equals. So again, this is the fish method. Always start with the letter. In this case, we got x. I'm going to make the tail first. That's a 0.4. That's our first number. I'll cross it down to the next number, 0.4. And I'll swing it back up to the next number, 1.6. And I end where I started at x. So I type this into the calculator. 0.4 times 0.4 times 1.6. Oh, I'm sorry, divided. I pushed the wrong... yeah, but I typed the wrong button in there. That's better. I got something a little different. 0.1 is x. Now that's 0.1. That's 1/10. It says to change this fraction to a fraction in lowest terms. So just push the double arrow button above the enter sign, enter button, and you get 1/10. By the way, in green that reads 1/10 anyway, so that's good. Alright, so this is our objective. You should be able to use rates, unit rates, and solve proportions. If you can do those 3, then you have accomplished the objective. Good job.